Have you ever wondered how the right electric motor is selected for a specific application? Electric motors are the driving force behind a multitude of industrial processes, from manufacturing machinery to electric vehicles, and even household appliances. They convert electrical energy into mechanical energy, powering the world around us. But selecting the right motor isn't as simple as picking one off a shelf. It's a critical decision that can directly influence the performance and efficiency of a machine or device. Selecting an electric motor involves a careful evaluation of several factors. These include load and speed requirements, environmental conditions, power supply compatibility, starting methods, and energy efficiency, to name a few. Each application is unique, and so are its motor requirements. The size, type, and specific features of the motor are all integral to ensuring optimal performance and reliability. So, are you ready to learn more? Let's dive into the key factors that govern the selection of types and sizes of electric motors. First off, we need to consider the load requirements of the application. It's all about torque and power. Now you might be wondering, what's torque? Simply put, it's the force that causes rotation. It's a crucial factor in determining the ability of a motor to perform work. On the other hand, power is the rate at which work is done or energy is transferred. Different applications have varying torque and power demands, which significantly influence the motor selection. For instance, a conveyor belt in an assembly line might require a motor with a high starting torque, while a fan or pump may need a motor with a constant torque over a wide range of speeds. It's important to remember that the motor should be capable of supplying the required torque and power without exceeding its rated capacity. So the first step is to determine the torque and power needed to drive the load. Next, we delve into the operating speed and duty cycle. The operating speed of an electric motor is a crucial factor to consider. Some applications demand a constant speed, while others need variable speed control. The speed requirement significantly influences the motor type and size selection, as different motors have unique speed-torque characteristics. Meanwhile, the duty cycle, whether the motor operates continuously or intermittently, is no less important. It directly affects the motor's thermal characteristics. A continuously operating motor generates more heat, requiring a higher insulation class to withstand the thermal stress. On the other hand, intermittent operation allows the motor to cool down between operations, possibly enabling the use of a motor with a lower insulation class. In essence, the operating speed and duty cycle are intertwined with the motor's thermal characteristics and insulation class. Therefore, understanding the speed requirements and duty cycle is crucial in motor selection. Now, let's consider the environmental conditions and physical constraints. The place where the motor will operate plays a crucial role in its performance. High or low temperatures can affect how well the motor functions. Humidity, too, can have a significant impact, potentially leading to condensation within the motor, causing electrical short circuits or corrosion. Now, onto physical constraints. It's essential to ensure that the selected motor can fit into the space available. It's not just about the motor's size, but also its mounting arrangement. The motor should be able to be installed in the desired configuration without any hindrance. So, it's not just about selecting a motor with the right power and speed, you also need to consider where it'll be operating. Is it a hot and humid environment? Do you have limited space? Can the motor be mounted as required? These are all key questions to ask when selecting an electric motor. So it's important to consider the environment and space in which the motor will operate. Power supply compatibility and starting requirements are another key consideration. The motor you choose must match the available power supply voltage and frequency. This is because motors are designed for specific voltage and frequency ranges. So when you're selecting a motor, ensure it aligns with your power supply conditions to guarantee optimal performance and efficiency. Now let's talk about starting requirements. This involves assessing the starting torque required for your application. Different applications have different torque demands at the start. Therefore, the chosen motor should be capable of providing the necessary starting torque. Additionally, the starting method also plays a pivotal role. For instance, some applications might benefit from direct online or DOL starting, while others might require soft starters. In conclusion, understanding the power supply and starting requirements is essential for the right motor selection. It's not just about choosing a motor that fits and works, but one that works efficiently and effectively in its specific application. Moving forward, let's look at efficiency, overload capacity, and maintenance considerations. When choosing an electric motor, it's essential to consider its efficiency. An efficient motor minimizes energy consumption and operating costs over its lifespan. It's a win-win situation for both your pocket and the environment. Next, consider the motor's overload capacity. Can it handle short-term overloads without overheating or incurring damage? This is a crucial factor, especially for applications that might require sudden bursts of power. Lastly, let's not forget about maintenance. Depending on the application, some motors might need more frequent servicing than others. It's important to choose a motor with maintenance requirements that match your available resources. You don't want to be stuck with a motor that needs constant attention if you don't have the time or manpower. So considering these factors helps ensure the motor's longevity and optimal performance. Lastly, we need to consider the cost, motor type, and any special features. The initial cost of a motor is certainly a factor, but it's equally essential to consider the long-term operational costs. These include energy consumption and maintenance expenses, which can significantly add up over time. Now, let's talk about motor types. Alternating current or AC motors are commonly used for general applications. They are versatile and can handle varying load conditions. On the other hand, direct current or DC motors might be preferred when precise speed control is crucial. Each type has its own strengths and applications, and the choice depends on your specific requirements. Additionally, don't forget to consider any special features required. These might include explosion-proof enclosures for hazardous environments, increased protection against environmental factors, or specific certifications for certain industries. In conclusion, by carefully evaluating these factors, engineers can choose the most suitable type and size of electric motor for a given application, ensuring optimal performance and reliability.